Okay, the shelf life video lecture and presentation. Presented a little bit earlier to help the people who are doing this in the open book exercise. Okay, that's what we're going to be covering. Bit of a flashback to last year's food science and chemistry, from which I'm sure you recall the discussion of water activity, which is very important for shelf life testing. See this video for reminders, but also you can probably go back and look at the lectures if you're interested. This is a good summary of the factors affecting microbial growth in food. If you click on the link, I think it takes you to the original place where I got this from. Above the line relates to the types of microbes, which obviously has some implications for the type of food. Again, remember halophiles and osmophiles from last year. Below the line is more important for this discussion about shelf life. Note the distinction between intrinsic factors, that is characteristics of the food, and extrinsic factors, characteristics of the environment. Obviously the food is what it is, the environment is the thing we need to control. For those of you looking at the open book resource, this is an excellent resource. Go to it, explore it. Note the tabs at the top, which are effectively chapter headings for you. A little bit more on that later on. So look out for the open book resource. There's a good definition of shelf life. Generally, when writing about a topic, it's a good idea to start with some clear definitions. Here, this is useful to start the open book resource. Say what shelf life is. Again, there's a link through the EU Fix resource there if you want to do more background reading. This, of course, is how consumers are given shelf life information used by from a safety perspective and best by from a quality perspective. Depends on the type of food, of course. Some definitions which you should be familiar with include these in the OBR, maybe also in the context of the range of business products changes involved. More on this in a moment. So there's some used products there which clearly will have use by dates on them for various reasons. Again, best before, nothing here you're not familiar with, including the general types of food that fall into each category. So we will talk about this more later in the tutorial. This is the framework which the exam questions will be based. So a company, the situation, is planning for some changes in its product types, discussed in the context of various issues. So for example, a medium-sized company that manufactures biscuits is planning a new, larger sensory facility. What requirements are required? So factors affecting shelf life. These are the main categories. Going back to the previous slide, some of these are intrinsic to the food, others are extrinsic, that is to say, arising from the environment. But this is one of these summaries which is often useful to drop into the open book resource, the OBR. Overall shelf life, as you might expect, is determined by the ingredient with the shortest shelf life. So here's a couple of examples, sandwich and a pizza. What ingredients do you think are the most important here in shelf life terms? Obviously, I think the pizza needs cooking, so there are some issues there as well. Similarly, if a low water activity ingredient is included with a high water activity ingredient, it is the latter that determines the shelf life. I will probably post the relevant presentation about water activity in the video link from last year, because I've redone that for the second year, so I do have a new video on that. If I remember, I will think on and do that. There are some special cases, such as where listeria may be a problem, and specific guidelines are available. There's quite a lot of detail here, and you probably don't need the detail. Consider whether the food you're interested in is prone to listeria, and then come up with a summary of how people would act. Preservatives, of course, can extend product life. Again, we looked at that last year in quite a lot of detail. Humectant may be a new word, but we are familiar with adding salt or sugar to lower the water activity. Note the comment on recipes. Once more, the lowest water activity ingredient is probably the key factor in determining the shelf life. There are issues in some cases with the potential for adversely impacting on consumer acceptance. I don't think this is particularly relevant to the exam exercise, but people in that group might want to have a quick read of the link document just to check. So how do we extend shelf life? Here's a couple of examples. Modified atmosphere packaging where oxygen may be replaced by nitrogen or carbon dioxide, so reducing oxidation reactions. Remember last year's content on polyphenol oxidase is a method that's widely used. Vacuum packaging is growing in importance for a range of products, but there may be issues with some food with the botulism organism. So there's a link there, potential issues with Clostridium botulinum, which you might want to have a read of. Active packaging is an area which has grown very rapidly with many applications. See the video for some background. You might want to look at other more recent videos because there's one I'll link from last year, and I'm sure there's lots of new stuff that's been posted in various places since then. Those of us who go back a while may remember when it was hard to find a tin that wasn't dented in the supermarket. It was sort of nasty and unacceptable, and also may compromise the safety of the food, and as I say, was unacceptable to many consumers. These days, much more attention is paid to packaging for large-scale transport, and also reducing the packaging at the consumer end of the process. The latter isn't a shelf life issue, but is a matter of interest to many people. You see, but in terms of packaging for transportation, you very rarely see tins that are dented these days. Temperature, unsurprisingly, the best planning for shelf life can be undone by poor temperature control. And we'll note the concept of a safety buffer zone. So we have a longer shelf life than is actually needed, than is actually the evidence suggests. So no, let me just say that again. So the shelf life is, quoted shelf life is shorter than the probable actual shelf life. That would be the buffer zone. Control of the manufacturing environment can help control extrinsic factors. This would be a case of including the shelf life is not impaired by environmental factors, rather than controlling as a way of controlling shelf life as such. And things we're very familiar with: cleaning, hygiene testing, stuff we do all the time in the food lab, for example. Many foods have long shelf lives, at least until they are opened. I wonder how many people actually store jam in the fridge after the jam jar's been opened. So how do we know the claim shelf life for a product is valid? There are a number of methods which the group doing the OBR will be summarising and defining. This is the most basic way. You take a food and you sample bacteria over its expected shelf life when stored under normal conditions. It takes a while, but it's still done in many cases. But if you've got something which has a very long shelf life, it's obviously going to take a very long time. And there are other methods which are perhaps used more often these days. This is a faster method, but again, not without issues. That's true of all the approaches to some extent. Here, microbes are added, that is to say pathogens, are added to samples of the food and growth rates monitored. If you want to know more, click on the Camden BRI link for more information. Another method, which is sort of related, I guess, predictive microbiological methods are computer-based software packages which allow the user to estimate a rate of microbial growth or get an indication whether growth of a particular microorganism will occur in a specified set of conditions. So this is obviously based on considerable real-world data. It's quite complex and would normally done by an outside body rather than the food company involved. Again, there's a link there to Camden BRI if you're interested. Okay, so if you click on the image of the pot, that links to a video on accelerated shelf life, and there's also a paper link there for people who are interested. ASL basically replicates the anticipated environmental changes to a food, but it does so in a much shorter time scale than the anticipated shelf life. So food, for example, gets heated and cooled over several times, over probably about 48 hours. It's a widely used technique. It's relatively low cost, but it requires specialist equipment, so again is normally done by outside bodies rather than food companies themselves. Finally, for completeness, survival methods. Based on consumer comments on food acceptability over time, it's not a shelf life method, so don't include this in the open book resource. It's just included here for completeness. Here's a plan to manage the overall process of understanding managing shelf life. Click on the image for lots of good advice. And I would have no objection to you using the image in your resource, providing you reference it. And there's some do's and don'ts from the last resource, the do's and don'ts for shelf life. So again, if you want to steal that, well, if you want to use it, just reference it back to the original source rather than me as having done a mind map. And then, of course, there is a British Standard for Censoring Shelf Life. Probably worth a quick read. There seems to be the only one, at least the only one I can find. You might want to have a search. As usual, log in via the library, go to databases, find British Standards, and then do a search for, in this case, a search for food and shelf life. If you search for shelf life, you get lots and lots of stuff, and it'll take a while to find what you want. Don't panic. Work as a team. Remember that your job is to summarise information. I'll do a walkthrough of how to do this for all the topics in the learning resources fairly soon, and we'll have a talk about it in a tutorial session either in real life or online. Okay, thanks for listening.